In January of this year, Robert C. Martin, the author of a lot of good books, such as Clean Code, wrote a blog post comparing type systems and unit testing. It was a rather controversial blog post, given that he suggested that people that prefer types should quit their jobs and never be a programmer again. And, you know, as social media, as we all know, is a really good place to get reasonable, rational, balanced debate, I thought maybe we could look at some of the responses to this controversial blog post. So at Alpa on Twitter says, everybody who shared this should be ashamed of themselves. On Reddit, 1792 says, yeah, Uncle Bob, fuck off. You're obviously a narcissistic arsehole who thinks too highly of himself. This one's my favorite. This is from someone called Combinatory Logic, who says, he is the Nigel Farage or Donald Trump of the software world. I'm Benjamin. I work at Stack Overflow. We're the team that brought you Stack Overflow. And this debate piques my interest because I'm interested in programming language design and type systems and that sort of thing. I find that stuff really fascinating. And one of the things that really struck me about the more reasonable comments in the debate on social media that this post generated was that the people that stepped in to defend type systems and the people that were siding with Robert C. Martin on the side of tests, they weren't even really talking the same language, right? So for example, so Thomas Petricek kind of agrees with me. He says, like, they're incommensurable, these two worldviews, right? The backgrounds of the people that program in strongly typed languages and like to use that is completely different than the background of dynamically typed programmers who prefer to use tests. And it leads to posts like this one, for example, this guy, Jake Wharton, I think he's done something remarkable. He's both sort of underselling and overselling the value of a type system in the same post, right? He says, type systems are a form of tests. Well, they're really not. I don't use a type system like I use a test suite. I use a test suite to verify the behavior of my code, whereas I use a type system to help me make sure my code is designed well. And so, like, if you're someone that really believes in the value of unit tests rather than type systems, you're not even really going to like understand what this is about. You're going to just say, well, what's the point in like having if I can write tests, then why would I bother writing types? For me, a type system is a lot more about driving the design of a system, and that's what I'm going to hopefully demonstrate to you today. Oh yeah, the other thing that struck me as absurd about this debate was it's not like types are the opposite of tests, right? In many ways, they're complementary. You need both of them to build a reliable system that continues working as you grow it, right? There's an idea called the Swiss cheese model. The Swiss cheese model perceives a system as a collection of layers, each of which are imperfect, right? Each of these layers has a hole in it, or some holes in it, but bugs only get through to production when the holes in all of these layers line up. So the game of software engineering, really, is to have as many of these layers as you can, and to use them as effectively as you can in order to minimize the number of holes in this, in order to minimize the likelihood of a bug getting through all of the holes in a system to production. So some of these layers of cheese that you might want to use: types, unit tests, certainly, but also code reviews, continuous integration, production monitoring. All of these are important and necessary tools that we humans use to reason about code and keep it correct as we grow a system. So, like I said, this talk is about using types to drive the design of a system, really weaving types into the programming workflow. And so in order to illustrate that, I thought we could build, I work at Stack Overflow, and I thought we could build one of Stack Overflow's features, which I think gives a particularly potent illustration of what I'm going to try and impress upon you. So the feature, I'm just going to quickly demo what the feature does. It's very simple. You guys probably can't see that, right? Let me ambiguate it. Is that big enough? I guess so. So Stack Overflow, as you all know, is a Q&A site, but you may be less familiar with our other product, which is a job board, a programmer jobs board, right? So here's what the jobs board looks like. It's at stackoverflow.com/jobs. And the thing that I'm going to demonstrate to you is our advanced search feature, right? So this this is the search box here supports a query syntax, right? So I can say, I can write a tag, I can look for C# jobs, and I can also say I want a job that's that's either a remote job, I want to be able to work from home, or it pays, I don't know, £50,000, right? And so if I look for this, like, I guess it's in kroner. Yeah, so this one, for example, this job's worth more than 55K. This one can be worth more than 55K if I'm good. Let me look for a remote one. This one, this one's remote, but it's also worth more than 50K anyway. So I thought we could implement like a miniaturized version of this feature together. Does that sound good? Some nodding, good. So let me just, so this is kind of, this little query language, it's kind of a miniature programming language, yeah? So it shouldn't surprise you that in the Stack Overflow code base, we have a miniature compiler for our miniature programming language. So let me, so this is a very sort of 1,000-foot overview of what a compiler does, right? Source code comes in, a text, a string, a file, text file comes in. We run it through a process called a parser, which extracts structured data from the syntax of your source code. Then the parser produces what's called an abstract syntax tree. I'll give you a demonstration of what one of those looks like in a minute. But it's basically an in-memory tree structure that reflects the source of the code that you wrote, right, in your file. And then the compiler itself, after the parser, is structured as either a short or long, whatever, series of operations on this abstract syntax tree. Some of them, for example, an optimizer that, like, for example, kills dead code, that would consume an abstract syntax tree and produce a different one with the dead code removed. But other ones, for example, the code generator that produces machine code or LLVM or SQL or whatever it is that you're targeting with your programming language, that's an operation that takes an abstract syntax tree and produces maybe a binary stream for the machine code that you're generating or something, or some ASM that you'll later run through an assembler, something like that. And another possibility for an abstract syntax tree after you've optimized it, etc., would be to run it in memory, right, over a collection of objects, or so that would be an interpreted language like Python or something like that. So here is the program that we're going to write. This is way too small. Let's. That's not the program we're going to write anyway. Here's the program we're going to write. No, that's not it either. That's better, okay. So can you guys read that all right at the back? Good. Okay, so here I've got a list of jobs with tags. Oh, I should say, obviously we're not going to implement the whole feature because it's quite a big feature, right? I'm going to implement 3 syntactic constructs. I'm going to implement tags. I'm going to implement anding of 2 queries. And I'm going to implement not, right? So Boolean negation. So here's an example, right, of an input query that has a tag C#, a tag Java. It's negating the Java tag, and it's using and to join them together, right? Any questions so far? So here I'm running this input string through the parser, and then I'm running the resulting query. This is going to be an abstract syntax tree, which I'll show you in a minute. I'm running it through an interpreter, and I'm running that for every job in our list. And so since I'm looking for C# jobs and not Java jobs, I'm not expecting job 2 to make it through because that's got Java in the list of tags. And I'm not expecting job 3 to make it through because that doesn't have C#, right? So when we run this program, eventually, only job 1 should appear on the screen. Any questions about what's about to happen? We're going to implement a miniature compiler, and we're going to do it in a type-driven way. OK, so first things first. What does an abstract syntax tree actually look like, right? So here's an example input string, and here's the abstract syntax tree that we are expecting a parser to produce out of it. So as you can see, the outermost layer of the tree, of the in-memory tree, is the AND operator, right? That corresponds to this central AND in the middle of our query. what this AND is doing is it's taking the left query here and it's ANDing it with the right query here, right? On the left-hand side, we see another AND, right? This one, and that's got the C# tag and not Java. Not is another operation, another node in our syntax tree. And on the right-hand side, we've got the OR node with the remote and salary operators. Any questions about what this abstract syntax tree does? Don't be shy. If you have a question, it's likely that the person sitting next to you has the same question. So, OK. So what does one of these abstract syntax trees actually look like in code, right? Let me jump back to Visual Studio. Make that a bit smaller. OK. So an abstract syntax tree is a type, right? If I give you an abstract syntax tree, all I can say is that I don't know necessarily what the user typed, but I do know that they typed a query, right? So we're going to represent this as a base class, an abstract base class. And for each of these types of nodes, and not and tags, we're going to represent that as a subclass of said abstract base class. So here's, for example, the tag subclass. It contains a string, which is the actual tag that you typed, e.g. C# or Java. So here's AND, right? It contains two recursive occurrences of a JQL syntax. JQL, by the way, I should say, is Jobs Query Language, JQL. I'm going to probably repeat the word JQL quite a lot, or JQL. An AND node contains the left-hand side of the AND operator. So in this example, the left-hand side of this AND would be tag C#, right? That's this AND here. And the right-hand side would be not with a Java tag inside it. So AND is a binary operator, and it's got two subtrees, right? It's got two JQL syntaxes inside it. Again, we don't know what sort of node those JQL syntaxes can be, because syntactically it's valid to have anything. And here's not, right? Not only has a single operand, but again, it's a subtree. It's not necessarily like a particular type of node. One thing I wanted to draw your attention to here is I've made these classes immutable, right? None of these properties have public setters. They're all just get-only properties. And I'm initializing them in the constructor, and I'm making sure that the argument to the constructor is not null in each of these cases. I do this as a matter of course for pretty much every class I write, not necessarily like compiler-y stuff, just like if I'm writing a MVC controller or something, I will give it a constructor and I will check that the arguments are not null. The reason for that is like if I were to give these public setters, I see this sort of code a lot, right? Just like get set, no constructor, and then like I'll say like new and left equals foo, right equals bar. The problem is, though, it's very easy to forget one of the fields, right? And then you end up with nulls in your system, and you have to check it, everywhere. If you have a constructor and you have null checks inside your constructor, you can be guaranteed that you haven't forgotten any of the fields. This is especially important, I find, when you're adding things to an existing class. It's very easy to add a new field that should always be set and forget to set it everywhere. So if you public int and no size or something like that. If I just do get set, I then have to manually find all the places in the code base where this node is being created and make sure that the size has always been set, right? It's a lot simpler to say int size and then set the thing in the constructor and then just literally chase all the compiler errors, right? This is like a big part of my workflow when I'm programming. I literally just I make a change which I know will break the type checker, and then I just go through and chase all the errors. Any questions about that? That's a very simple lesson. Yeah.
Since you do that a lot in your day, do you have like custom exceptions to motivate yourself, like all the 3 errors going, or anything to do with that, or just the same?
Do I have the question was, since I do this a lot, do I have custom exceptions for when an argument is null? Is that what you're saying? I think the system.argument null exception is a perfectly good thing to use here. It's what it's for. Yeah, and everyone understands it. If I had a Benjamin null exception, people would be confused when they saw that in the code base. At my last job, we had a class called the Boolat Recommendations Engine, because the person that wrote it was called Boolat, and we couldn't bring ourselves to change it even years after he left, because it was too good of a name. Okay, right. So that's what a syntax tree looks like. Okay, back to the slides. Oh yeah, I just wanted to draw your attention to a possibility here, right? In most cases, right, if you're implementing something like a programming language, you know all of the types of nodes in your system, types of syntax tree nodes in your system, right? In this instance, there are 3 and only 3. We don't necessarily want this base class to be open to further subclassing in another module. And so a trick I occasionally do, it's a little bit heavyweight, so it kind of depends on personal taste, is I make the JQL, I would make this base class, I would give it a private constructor, and then I would nest these 3 subclasses inside it, right? That means you can't add a subclass of the JQL syntax because you have to be able to call your base class's constructor. You can't add a subclass without modifying the actual JQL syntax class. That's just a little trick that I sometimes like to use. Okay, any more questions about the representation of an abstract syntax tree? No? Okay, how much time have I got? Good. Okay, so now that we have written this abstract syntax tree, we need to be able to process it, right? We need a way of taking an abstract syntax tree and I mentioned earlier that a compiler, a typical compiler like Roslyn, is structured as a sequence of operations that modify a syntax tree in some way, and then eventually another operation that generates, in Roslyn's case, it's IL. In many other cases, it's like native code or LLVM or something like that. So what do these operations actually look like? We need a way of implementing a function which looks at a syntax tree and perhaps performs a transformation, returning a new syntax tree, or generates code, or whatever, type checks it, or runs some diagnostic, depending on the requirements of your programming language. So, given that there are 3 types of nodes, right, and not, and tags, each of those nodes has its own meaning, and an operation on the syntax tree should treat each of those nodes as its own case. Yeah. So we need a way of examining the type of node that you're looking at, right? One simple way of doing this would be to just use the is or as operators, the C# is or as operators, is and check, is and cast, I should say, or as and check. Or we could use the new C#7 pattern matching stuff. Or we could equip our base class with an enum, like the node type, and then switch on that, and then downcast it to the actual nodes. All of these suffer from a problem, right? The main problem, in my opinion, is that you don't get any checking to ensure that you have covered all of the cases, all of the possibilities, all of the different types of node in your operation, right? So if I were to come back here and add another type of node called or like salary or remote or whatever, I need to make sure that I've updated all of the operations in my compiler, because otherwise a user could type an or query and then suddenly I don't know what to do with it and I throw an exception and then the user's unhappy, right? And I would like compile time feedback for that, right? And so if I'm saying like if node is and then do this, if node is not, if node is tag, whatever. Likewise, the C#7 pattern matching switch, I don't get any feedback from the compiler when I add a new node and I forget to update one of the functions. Yeah? Any questions about the shortcoming of is, as, and switch? The other downside of is and as is that you could forget to, in the case of is, you could downcast it to the wrong type. In the case of as, you could forget to check it for null. Either way, it's a bit sort of syntactically clunky, in my opinion. The pattern matching stuff does make a big improvement on this, but like I said, it still has the shortcoming that it doesn't require you to cover all cases. Okay, so the design I came up with here is something that I think is quite syntactically lightweight, but it does require you to rewire your brain a little bit and think a little bit more abstractly about the evaluation model of your program, right? So it looks a bit like this. I'm calling it match just for to to evoke the notion of pattern matching, C#7 pattern matching. But it's very sort of syntactically lightweight, and I'm leaning on lambdas to do this, right? So the idea is that so this is a function that takes a query and a job, and it tells you if the job satisfies the query, right? So this is called continuation parsing style, right? The way I define an operation on a JQL node is I say, well, there are three possibilities, right? It could be a tag, it could be and, or it could be not. And I need to define a way to handle each of those cases, right? The way I'm doing it is I'm writing those out as lambdas, and then I'm passing it into the node, so the node can decide which of these lambdas to call based on its own type, right? Any questions so far? I'm about to type it out, so if you're confused now, hopefully seeing it written out will simplify that. Okay. So we want to write. Should I write? I'll write the implementation first, right? So I'm going to write an abstract method, and we want the caller of this method to be able to choose the return type of the operation that they're writing, right? It wouldn't be very good if we were to hard code bool as the return type, because then that would preclude us from compiling it into an Elasticsearch query, which is something that we do at Stack Overflow, or like performing any sort of tree rewriting, because then the return type would be JQL syntax again. So we need a generic type here. We need to parameterize the return type. So abstract T, and I'm going to call it match, as I said, to evoke pattern matching. When you're calling this function, you need to provide a lambda that covers each of these three cases. So the first case is a tag, right? So so this is going to be a func, a lambda, which returns a u. And its argument is whatever was inside the tag, right? So this is a func from a string to a u, and I'm going to call it tag. Not a u, a t. Help me out if I type something wrong, because I am actually typing this, and I probably will get something wrong. What about the second possibility? The second possibility is that I gave you an AND node, right? So AND has two subtrees inside it, and so the continuation that I'm going to pass, once I've checked that you gave me an AND node, I'm going to have two subtrees to give you, right? So this is going to be a function of two JQL nodes to a t, right? And then, of course, not has a single subtree inside it. And so if I perform my type test and learn that it's a not, I have one subtree to give you. Any questions so far about how this is going to go down? OK. So now we need to, this is an abstract method, so now, of course, it needs to be public, of course. So now we need to go ahead and implement this abstract method in the three subclasses. So if we're looking at a tag node, override t match, oh god. Sometimes computers are too helpful. Okay, so we're looking at tag. This is the tag class, and so the method, the func that you need to continue the method with is the tag func, right? And the thing that we pass it is the value of the tag. Any questions so far? Okay, I'm just going to copy and paste this. Right, so now we're looking at an AND node. I have two JQL syntaxes to give you, and the correct func to call here is AND, right? And left and right. And in this instance, we're looking at not. And so the correct func to call is not, and it's going to be operand. Okay, any questions about how we're using this virtual method to allow the subclasses to choose which func to call? Any questions? Okay. So now what remains is to actually implement that checking operation, right? The operation that takes a query and a job and tells you whether the job matches the query. So this is in interpreter. So I left this as a to-do. Right, so I've got this node, and so what can I do with a node? Well, the only thing I can, well, that's obviously a recursive call to this. The only thing I can do with a node that's not one of these extension methods, which I'm going to show you the other one of in a minute, is match the type of the node, right? And in order to match something, I need to give it 3 functions. So the first function is the tag function. So what do I do if you gave me a query which is just like C#? I've got a job, and I've got a tag. What do I do with it, right? So this is a lambda, as I illustrated earlier. So I want to see if the tag is in the jobs list of tags, yeah? So j.tags.contains tag. Whoops. Right? If it's an AND node, I've got 2 JQL syntax subtrees. And I want to look at each of these subtrees and see if they, if the job matches that query, yeah? So I need to recursively check the left subtree against the job, and check the right subtree against the job. And I need to AND those two, the bools that those two return, I need to AND them together. Yeah? And finally, not takes an operand. And again, I want to recursively check that operand against the job, and then I just need to negate it. Any questions about this? About the recursive traversal of this syntax tree? No? Sure? OK, so what I wanted to illustrate here was that this is a type-driven style of programming, right? So the first thing I did was I wrote down the signature of this check function. You know, I wrote that it takes a JQL syntax and it takes a job and it returns a bool. And knowing that I need to scrutinize the JQL syntax in some manner to find out what type of thing it is, the only thing I can do with it is match it, right? And then in each of these 3 continuations, in each of these 3 branches of the methods, there's only really one thing I can do. It's kind of obvious what's correct at this point, because I have a string for the tag in scope. It's kind of obvious that I need to I need to call contains, right? And likewise for and not, it's kind of obvious which bool I need to return, right? There's nothing in the type system that stops me from saying, right, this always returns false, right? That's a bug. The type checker doesn't help me here, and I think it would be unreasonable to expect a type system to do so. This is what unit tests are for, right? But the type system nonetheless helped me think about what I needed to do in each case, right? I split the node into 3, split the method into 3 branches, and then in each branch it was kind of obvious what I had to do thereafter once I'd done that bit of work. Any questions about this fake pattern matching thing? Okay. What did I have next? Oh yeah, right. So last time I gave this talk, this proved to be a little bit controversial, right? The classic OO, object-oriented style of writing this code would be to put a virtual method on the base class, JQL syntax, called check, that returns a bool, and allow each of those 3 subclasses to override that virtual method and return that bool, right? What I don't like about that in this instance is, first of all, it couples knowledge of, like, if you have a lot of operations, like generating an Elasticsearch query or like doing an optimization, the JQL syntax nodes have to know how to do that, right? The knowledge has to be inside the syntax tree, where the syntax tree's job is really just to be a syntax tree. But more importantly, it's about what operations do you want to make easy for future developers, right? Which direction do you want it to be open in, right? So the virtual method style makes it easy to add new types. For example, if I wanted to add like or salary or remote to my JQL syntax class, that would be easy. All I have to do is override the virtual method for each of the operations that I have, because like I've got a virtual method for check, and I've got a virtual method for generate elastic, and I've got a virtual method for like rewrite you know. I just have to override each of those virtual methods in the new subclass that I'm adding. But what it makes difficult is to add a new virtual method, because if you have lots of data types, you have to go through and change every single data type in order to add the new operation to the type. Yeah, lots of possible cases. I have to override the new virtual method in each one of those. The pattern that I implemented, the lightweight visitor, I call it, makes it easy to add new operations because the operations are decoupled from the syntax tree itself, but it makes it hard to add new types of data because I have to go through and change every function that's been written already, right? This is called the expression problem. It was named by Phil Wadler, who is one of the towering figures of the programming language design community. He implemented Java generics, and he invented type classes and stuff like that. So you've probably used his work, at least indirectly. He called it the expression problem because it's particularly relevant to this sort of code, right, where you have an expression tree, a syntax tree, and you want to be able to add new types and new operations because you want to be able to evolve your language, but you also want to be able to write new optimizations for your language or add a new backend to your compiler or something like that, yeah? Don't underestimate how big of a deal the expression problem is. It's one of the central tensions of software engineering. If I've published my base class and I have a bunch of subclasses in consumers of my library who I've never even met, if it's an open source library, I can't just go ahead and add a new operation that they have to override because I'll upset everyone, right? I'll break all of their code as soon as they update. And likewise, if I have operations that are defined in other people's code, if I add a new, if I'm using the functional style of writing code, if I add a new operation, if I add a new subtype, I should say, all of my clients have to change all of their existing functions, right? Any questions about the expression problem? OK, right. So let me just go back to my table of contents. So I've shown you what an abstract syntax tree looks like, and I've shown you what a simple interpreter looks like. What's the time? Have I got time to? No, not really. So now I'll show you what a parser looks like, OK? Now, a parser differs from an interpreter or a type checker or a code generator in that it doesn't operate on an abstract syntax tree. It produces an abstract syntax tree from a string, right? So I obviously can't hope to use that match method that I just wrote to produce an abstract syntax tree because it's a method on the abstract syntax tree already, right? So this is going to require a new approach. I wanted to show you a style which, first of all, illustrates the... So I showed you the visitor pattern. I want to illustrate the other way of flipping the matrix, right? The reason for this, the reason I went for the visitor pattern in the syntax tree is that there's a small and closed set of nodes, but there's a potentially large number of operations on the tree, right? For a parser, there's a lot of ways of building a lot of parsers in the world, a lot of different ways of producing a structured data from a string. But you can only, once you've got a parser, you can only really do one thing with it. You can parse a string, right? So the style of parser I like to use is something called a parser combinator library. Now, this idea, it's an old idea. It's not my idea at all. But it's about representing a parser as objects, which do a simple thing, and then a number of operations to combine those simple parsers into more complex and interesting parsers, right? The code that it kind of looks like, the code that it produces when you write when you write code using a parser combinator library, looks kind of like a script, like an embedded domain-specific language in C#, which sort of defines a script for a given parser to follow. So let me, I've put a sort of miniature example up the top, but I'm going to show you a more interesting one. Let me shrink this. OK. So for example, here's a parser that parses a not JQL node, right? A not JQL node is the string not, and then some other JQL node, right? So that might be a tag, or it might be like a parenthesized group of other nodes, right? Likewise, and I'll show you. So the way we parse this is we parse like a single expression, and then we parse the word and then we parse the next expression, okay? So for example, a tag, this is probably a better example. I'm going to parse a sequence of characters. I'm going to do it in between two square brackets. And once I've done that, I'm going to produce a tag node, right? Any questions about what this parser combinator idea looks like for a consumer? I'm going to implement it in a minute. So basically, it's about building an expression, a C# object, using this parser type, using a collection of methods that the parsing library provides that kind of looks a bit like a domain-specific language. Okay? So let's think about the design of what a parser does. So first of all, there are a few ways to create very small parsers that do like exactly one simple thing. The first parser we implement, the first parser that we provide is, I'm calling it return, and it does nothing, right? All it does is produces a value, right? In this instance, it's the integer 3, but it might be like a string, or it might be a tag, right? Or a not node. Another parser we want to support is a parser that always fails and produces a parse error. Okay? It doesn't do anything to the input stream of characters, it just fails. And then the third primitive parser is one that consumes a character from the input string, crawls along the input string by one character, and returns that character. Yeah. There are also a few operations to take these simple operations and build more complex ones out of them. Right? Oops. We want to be able to sequence two parsers, right? So if I parse the string foo, and then if I'm trying to recognize the string foo bar, I might structure that as like parse the string foo, then parse the string bar. Yeah. I'll go into a bit more detail of how that works, right? There's also the possibility that I'm looking at so when I'm parsing a JQL syntax tree, I don't know what the user's going to type, right? They could type a tag, they could type an and query, they could type salary. All of those are possibilities that my parser is going to have to handle. It doesn't know which one to expect, right? So we need a way of choosing between two parsers, right, based on what the user typed. So if the user typed a tag, then I should delegate to the tag parser. If the user typed an and query, then I should delegate to the and parser. And so that would be like, I had it here. So this expression parser says like, a JQL node is either a tag, or it's a not node, or it's a expression, a parenthesized expression. I forgot and there. Oh no, I didn't know it is. And then for an expression, it's a single term, and then it's an and, then it's the word and then it's the rest of the expression. Okay. Right, so let's think about how are we going to implement this parser, right? What type are we going to use to represent a parser? Well, a parser is a function that takes a string and produces some sort of structured data of a given type, right? So a parser for bools would take like the string true or the string false, and then it would produce this t would be a bool, yeah? And it would fail on any other string. But if you actually get down to thinking about how we're going to support the operations, particularly then and or, it turns out that this simple type is not quite enough. So let's think about how you would parse two parsers in sequence, right? So the string foo bar, foo then bar. If I parse the string foo, I then need to look at the rest of the string after I parsed foo in order to parse the word bar, right? Does that make sense? So actually, it turns out that it consumes, so here's foo bar, right? The first parser has to leave something behind after it's consumed its part of the input string, has to leave something behind so that the second parser has something to look at, yeah? So instead of returning just a t, I need to return a pair, right? I need to return the structured data that I parsed, the value, and I need to return the leftovers from the parser, yeah? The remaining input string for the second parser of the then method to consume. Okay? Another subtlety about the then methods is that once I've parsed the string foo, that is a successful parse by itself, right? I have a result to give you, right? So if it was like foo and then return 3, by the time I've parsed the word foo, I have a 3 for the, before I've even thought about what the next parser is, right? So the general version of this then method actually takes a parser which returns t's, and then it's able to use that t to choose what the next parser is, right? I'm seeing some confused faces. Do you have any questions? Don't be shy. I'm going to implement this in a minute, so if you think about how to articulate your question and then come back to me. OK, what about the OR method, right? This one, the one which chooses between a pair of parsers, right? Well, in general, in the presence of OR, so here at the top is a parser that can either parse foo or bar, right? Those are the two valid inputs for this parser. In the presence of OR, a given input string may have more than one valid parse, right? So here's a sort of slightly pathological example, but here's a parser which parses foo and returns the value 1, or it can parse foo and return the value 2. How do you know which one is the correct one to return, right? The simplest way is to just return both of them, right? Each of which has their own leftovers. Yeah? So in fact, rather than returning a pair of t and string, we're going to return a list of t's and strings, yeah? This is also how we implement failing, a failure parser. We just return no results, and it's also how we implement the do-nothing return parser. We just return a single result and don't consume any input. Yeah? So this is the type we're going to be working with. And hopefully you'll never forget it, because there's a nice nursery rhyme, thanks to Fritz Ruhr. A parser for things is a function from strings to lists of pairs of things and strings. OK, so let's actually sit down and write those functions that I wanted to write. So here they are. I've just got them all returning null at the moment. So here's my parser type, my delegate, a function from strings to lists of pairs and things and strings. OK, so how are we going to implement a parser that doesn't consume any input but returns a single value? OK, well, so like I said, it's a delegate, which means it's a function, and it takes a string as an input. So let's say input arrow. And what's the return value, right? Well, I said we don't consume anything from the input string, so the remaining input is literally the string that we were given, right? There's no difference between the input and the leftovers. And the value that we return is the value that we were given, right? So I'm going to return a singleton list containing the value that I was given, this value, and the same input that you gave me to parse. Yeah? Any questions so far about return? Do shout out if you have any questions, interrupt me. OK, a parser that fails, again, this is a function because parsers are functions from strings to results. A parser that fails is a parser that doesn't have any results to give me. Yeah? So I'm just going to return an empty enumerable, empty of, and it's this tuple type. Yeah? I'm using the C#7 tuples here, by the way. It's a pretty nice new C#7 language feature. OK, this one's a bit more interesting. What about a parser which consumes a single character of any character, right, and returns that character, right? So this is a parser which returns a char. So again, it's a function from an input string to, right. Well, if the input string is empty, then I can't give you a character, right? So input.length is 0. If it's 0, then I can't do anything, right? So I'm just going to fail. If you did in fact give me an input, then I want to so I want to pop a character off the input, and that's my result. And the leftovers, the remaining input, is the rest of the string apart from the first character. Yeah? So I'm going to return a singleton thing. So this is going to be the first character of the input, and the leftovers are going to be the remaining input. Did I get that right? What did I do wrong? I need to cast that to an immemorial, I think, maybe. What have I done? Input of 0, that should be a char, and that should be a char, I think. I think I got my type annotation wrong. Oh, it's because that's not a char either. There we go, that's what it is. I think I don't need that cast after all. Okay, so there's a parser which consumes a character from the input string, and then it passes the rest of the string to the following parser, which I will show you now. So how do we implement a parser which runs a first parser, and then right, so this is a parser that runs, we're going to return a parser, and what that parser is going to do, it's going to run this P parser, and then it's going to use the result of P, pass it to F, and then run the resulting parser on the leftovers that the P parser produced. Okay? So it's going to be a function, of course, because parsers are functions. So to run the P parser, we give it the input string, right? And so this is going to be a immemorial, a collection of things. So and this second parser is going to return a collection of things. So I want to select many. I'm just using the normal link select many here. So this is going to be a tuple. Whoops. Each result in the output of a parser is a pair of a result and leftovers, right? So I have a function which needs a t, and the tuple is a pair of a t and some leftovers. So the only thing I can do with f is give it the t from the tuple. Yeah? Now, what do I do with the resulting parser? I want to see. No, it's not going to. This expression, right, we took a func of t to parser of u. We gave it a t, so now this expression is a parser of u, yeah? What do we do with a parser of u? Well, it's a function, so we apply it to something. What do we apply it to? We apply it to the rest, the remaining input from the first parser, right, which is tup.leftovers. Okay? Any questions about then? It's a little bit, it's very terse, so there might be some questions about it. Sure? Okay. What about a parser which can run two parsers? Well, this one's pretty simple. Again, it's a function. Parsers are functions. We are going to run P on the input, and then we're going to run Q on the input. What do we do with P and Q? Well, each of them returns an enumerable of results, and so we just want to return all of the results, right? So we just want to concat the two enumerables. So P input dot concat Q input. So those are our five primitive operations, right? It turns out that this is enough to allow us to now work at a much higher level. We can talk about combining parsers using these 5 primitives, rather than talking about like looking at an input string, writing a function that looks at an input string and then produces a result from that thing, produces some leftovers, right? So, yeah. Okay. The question was, why does this OR parser use the concat? I obviously didn't explain it clearly enough. Okay, so we've got two parsers, right, P and Q. And a parser is a function, right, that takes an input string. So we want to write a function from an input string to a collection of results, right? Each of these parsers produces a collection of results, right? Once I've applied, so the first thing I do is I apply P to the input string and I apply Q to the input string to see what results those two parsers returns, right? But as I said earlier, in the presence of alternatives, a given input string may have multiple valid parsers, right? So it's possible that this P just failed and didn't return any results, or this Q failed and didn't return any results. But in general, they may each return multiple results, yeah? And so the result of combining two parsers in this manner is all of the results of the first parser and all of the results of the second parser. Does that make any sense? Yeah? Any more questions? Have I done a good enough job of explaining that now? There might be some. Are you sure there aren't any questions about this then method? OK, all right. So I was talking about how these 5 primitives allow us to talk about combining parsers, right? Not about examining an input string and like doing a character at a time. We can work at a much higher level and combine parsers, right? So for example, what's a good example? OK, so here's one which maps a function over the result of a parser, right? So a parser which maps a function over the result of a parser runs the first parser on the input string, takes its result. Remember, then takes a func as its argument. So it takes the result, and the parser that we return doesn't do anything. It doesn't change the input string at all. All it returns is the result of applying the function to the result. Yeah. Likewise, we can do a linky there, which takes a predicate and fails, returns no results if the predicate does not, if the result of the parser does not match the predicate, right? So again, we're going to use the then methods. We're going to run the predicate over the result of the parser. If it succeeded, then we don't do anything. But if it failed, then the parser fails. Yeah. One more thing I wanted to show you was, I guess you guys probably know that the link query syntax, the from select thing, is not bound to iEnumerable. Any type that implements a select many method with the correct signature, you can use from x in thing. So I've written select many here. It's basically an alias for then with a little bit more stuff at the end of it. But that allows us to write quite a nice sort of script style way of writing a parser, right? We can use so the way you read a from select thing for a parser is you just read it from top to bottom. So this says run the before parser, run the parser, and then run the after parser. This is a parser. This is a function which takes a parser and runs it surrounded by 2 other parsers, right? So that would be like parentheses. So in fact, in this example, for a tag, I'm saying it's a bunch of characters in between an open bracket and a closing bracket, yeah? So that's kind of nice. Anyway, the point of this, though, is that this is a library. This is reusable codes, right? I haven't mentioned JQL syntax anywhere in this. It's the client code that talks about JQL syntaxes. But the design of this library is the type, really. We wrote down a type which supported the operations we wanted, and then these operations kind of wrote themselves given what we expected of the type, yeah? So we kind of let the type system drive the design of this parsing library. There was one more thing I wanted to say, but I forgot what it was. It was down here, I think. No, it's gone. Never mind. OK. Are there any more questions about this parsing library? No? OK. So I've shown you all this. OK, oh yeah, I just wanted to talk about, I've written a library which does this, but it's basically faster than the stupid thing about this implementation. The really stupid thing is that I return a string of leftovers, right? A string is a sequence of UTF-16 characters packed into an array, and so that means every time I consume a character, I copy almost the entire string, right? So this is a really awful parser. It's got really awful asymptotics because every time you consume a single character, you copy the rest of the string into a new string and then send it on to the next one, which is just appalling. In my library, which is on GitHub, I'll put the slide back up. All I do really is I keep the string as it is, and I have a pointer saying where am I in the string currently, and I just move it left and right as necessary. I also have tools for parsing expressions in a slightly nicer way. Like this JQL syntax is an expression. So in the real implementation in our code base, we're using my expression parsing stuff. And I also support lazy parsing, so I can parse a stream or a text reader rather than just a string which I know is fully in memory. I have a couple of competitors in the parser combinator space. There's fparsec, which is an F# library. That's very good, but it's not easy to consume from C# because it's an F# library. You have to pull in the whole F# standard library, and some of the operators have really strange names if you look at them in C#. There's also a library called Sprache, which I guess is probably a German word. I don't know. Have I pronounced it wrong? Sprache. Thank you. I basically, we were looking at tools for parsing for this JQL feature, and we looked at Sprache, and I basically said I can do a better job than Sprache. I think Sprache has some efficiency problems which basically can't be fixed without rewriting the whole library in a backwards incompatible way. So that's what I did. I rewrote it, and I called it Pigeon. Oh, geez, I've got to wrap up. I just wanted to very quickly talk about the downside of this match method, right? This one, right? So each of these lambdas is a closure. We reference the job, right? If you look at the IL that Roslyn produces for a closure, what it does is lambdas basically compile into a class, right? And when you pass a lambda around, what you're actually passing around is a reference to the class's method, right? So the problem with the match method is that every time you call this check thing, you allocate a new closure on the heap. The idea that's what produces such bad performance, right? It's like 10 times worse than the fastest implementation that I benchmarked, and it has heap residency, whereas all the others just live on the stack. So my idea was basically let's write a compiler plugin that looks for calls to this match method and rewrites them into the switch statement that you would have written in the naive way, right? The untyped switch statement that you would have written in the naive way. Here's a very simple algorithm. I haven't really got time to go through it, but this is what the sort of generated code looks like, right? So you'd write this match method on the left, and I'm going to generate a method which just does like a switch statement, and does the switch and cast and returns the right thing. The code on the right-hand side has no allocations, right? But the code on the left-hand side does, because I'm closing over this y variable. This is kind of a crap example because I should have used the JQL thing, but this is like a different language which uses which does like arithmetic expressions plus and times or something like that. The problem is really that Roslyn is not at the moment set up for writing compiler plugins, writing user-defined optimization parsers. So I'll show you kind of what the code looks like. It's a bit messy. I basically had to, there's a load of crap in this top-level method, which I have to manually import all the right C# references, and I have to sort of manually invoke the compiler after having run my own stuff. I would like to see a future Roslyn API which supports plugins. In the meantime, at Stack Exchange, my esteemed colleague Samo has we've written our own bit of infrastructure which supports compiler plugins. And what we're using it for at Stack Exchange is localization. So rather than look up a translated string at runtime, we literally just rewrite the calls to localize. We rewrite those into a big switch statement based on the user's current language. Okay, that's more or less it. The takeaway from this talk is that a type isn't like a test, right? A type is a design tool. It's a thinking tool. If you allow the types to drive, or even in the case of that parsing library, the type kind of was the library, and we just had a bunch of methods which the type sort of naturally supports, right? And you can use that to produce some very simple code, or at least some very terse and readable code. Often, though, that requires sort of rewiring your brain to think outside of the imperative mode of thinking, right? So the parsing stuff, this is quite sort of it doesn't necessarily look that much like C#. It's very sort of expression-y and not very like you'd expect to see some for loops if you're iterating over a string, right? And like this is kind of a slight abuse of the link syntax. So my advice would be try learning a functional language. If you could follow what I was doing today, then functional languages are well within your grasp, I promise you. Don't be scared. The downsides of this style of writing code I touched upon slightly. If you're using a lot of closures, as I was earlier, then you're gonna end up allocating a lot, as I showed you. I would love to see a Roslyn tool. I would love to see support in Roslyn for writing sort of pluggable compiler optimizations. So, for example, I could write like I could ship some code like JQL syntax in a library, and together I could ship a compiler plugin which allows you to write type-safe code but generates fast imperative code. Also, I wanted to bring to your attention the fact that there's some interesting language design going on right now, particularly in like the Rust and Go languages, where they're using the type system to help you reason about the performance of your code and the correctness of your code, right? So Rust has what's called a borrow checker, which basically makes sure you don't leak memory. That's a performance issue, but they're using the type system to help you reason about it. Okay, I've got maybe a couple of minutes for questions. No, I've got -1 minute for questions. So see me after if you have any questions. Thank you very much.